Example 5 is 6x squared minus 11xy minus 10y squared. So again, we want to factor. This trinomial is in descending order according to the variable x, so that's okay as far as the order. It does not have a greatest common factor, so I'm going to multiply the first number times the last number, just like the other problems. So that gives me negative 60. Make a list. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, or 6 times 10. Okay, I'm looking for the two numbers that will subtract, right? Because it's negative, I want what's going to subtract to give me negative 11xy. Okay, as I look at my list, which two numbers would subtract to be negative 11? 4 and 15 would subtract to be 11, and 4 and 15, what about the signs? If I need it to be a negative 11, the 15 is going to have to be the negative number. The variables that you attach to these have to match exactly with what's in the middle term, okay? So if there's 11xy here, that has to be 15xy and 4xy. So that if I combine those two terms, it would equal what I have in the middle, okay? We will still divide by the leading term, 6x squared, and then reduce. Okay, if I reduce 2 will go into 4 2 times, 2 will go into 6 3 times, and then I can also divide out my x's, so I would have 2 over 3, x over x squared would be x in the denominator, and this y would still be in the numerator. We haven't divided that out. Okay, reduce. 3 will go into 15 5 times, 3 will go into 6 2 times. So I have negative 5 over 2, x over x squared leaves me with an x in the denominator, and the y is still left in the numerator. So from bottom to top, write my two binomials, 3x plus 2y times 2x minus 5y. And we could check this. This would equal back to the original polynomial that we started with. It's just that whenever you have two variables, like x and y here, and an x squared and y squared, in your answer you will have to have xy, xy. Okay, it should always work out like that. All right, one more kind of exception or problem I want to show you is number 6, 12x cubed plus 22x squared plus 6x. Okay, it is in the right order, but it does have a greatest common factor. So before we do anything else, we're going to factor out the GCF. So what will go into every term? 2, and they all have an x. So 2x into 12x cubed will be 6x squared. 2 into 22 would be 11x. 2 into 6 would be 3. Now we're working with the trinomial that's in parentheses. So as far as our process of factoring that, it's just like the previous problems. I'm going to multiply 6 times 3, that's 18. Make a list. What are we looking for? What two numbers will add, because it's positive, add to be 11x. Okay, so we know that'll be 2 and 9, both positive. Attach x, so I would have 2x and 9x. Divide by the first term of this trinomial, which is 6x squared. Reduce. So as I reduce, I would say 2 will go into 2 one time, 2 will go into 6 3 times. So I have 1 over x squared is x. 3 will go into 9 3 times, 3 into 6 2 times. So 3 over 2, x over x squared leaves me the x in the denominator. So I would have x plus 1 times 2x plus 3. Okay, but I could not just circle this and say, okay, this is my answer, okay? Because if I check this, would these two multiply back to give me the original? Okay, we always want to get back to the original. It does not. So I have to make sure that I include my common factor that I took out from the beginning. I have to include that in my answer. Okay, so if I multiplied this together and then distributed back my 2x, yes, it would equal back to what I started with. So if you ever take out a common factor, don't forget about it. Okay, write it as part of your answer, always. Okay. Number 7 is the last problem on your handout. X squared minus 6x minus 40. Now this one looks just like what we did in the previous section of videos. There is an understood 1 that's in front of this. So if you would like to do all of your trinomials the same way and just be able to say, okay, if it's a trinomial, I'm going to do this, then you can. Okay, there's an understood 1, so I would say 1 times negative 40 is negative 40. Make a list. 1 times 40, 2 times 20, 4 times 10. It's negative, so I want to know what's going to subtract to be negative 6, which would be 4 and 10. The higher number, the 10, would need to be negative and attach x. So I would have 4x and negative 10x. Divide by 1x squared. Divide by 1x squared. And reduce. When I reduce, I'm still going to have 4 in the numerator. X over x squared is x. Still going to have negative 10. X over x squared is x. So bottom to top, x plus 4 times x minus 10. Okay, so I wanted to show you that even the problems we have done in the previous section can be factored this exact same way. Okay, it will work for every trinomial. So if you want to just have one method for all trinomials, then this would be it.